little hints and such, but try to get you to get some good practicing in here and get some help as needed. All right, so with number 3, I think there's a little bit of a rewrite that we'd want to do before we got too far into this. We're supposed to, the directions you can see from above are to find the derivative, right? Differentiate. So we're looking for h prime. We're going to differentiate the left side. But what should we do to the right side before we get busy doing derivative stuff? Any little rewrite? Yeah, I think, we do the negative exponent on the x there. So I would say h of x equals e to the negative 3 times x to the negative 1. I think if you write it out like that, it'll make it a little bit easier. So take a minute, look that one over, see what you can do, and I literally will give you like a minute. So hopefully, so with this one, obviously is a composite function. So as we differentiate this, we want to remember that the derivative of e to the u, where u is just some generic unknown function, the derivative of e to the u is e to the u times u prime. And so in this case, u is negative 3x to the negative 1. So we'd say this is derivative is equal to e to the u. And u prime should be easy, but sometimes we make mistakes. And maybe some of you are tempted to write this. You see why somebody might want to put that? What are they accidentally doing if they do that? Well, it's sort of. They didn't differentiate, they integrated, right? So this is the time of year when that thing, what he just said, happens a lot. When you know full well that the intention is to find a derivative, but you just accidentally find an antiderivative, or vice versa. So please be super careful to not do that. That, of course, was wrong. This would be 3x to the negative 2. We good? Okay, awesome. So I mentioned this last time, chapter 5, unit 5 in your book and in your notes is really about skill building, skill development. It doesn't introduce any new applications, but old applications are still in play. And I think question number 4 is a nice example of how those old applications can be seamlessly integrated into this material. So if you would, take a look at number 4. It says, find the local min and max of f of x equals x times e to the x, and you're supposed to justify your answer. And this really ought to be able to be done without a calculator. So take a minute, explore around through this, see what you can do, but don't use a calculator. Guys, this is really, I hope, quality review for you as far as tying old things into new things. So this says, of course, find the local min and max. I want to ask you guys, what are the candidates for local mins and maxes? Not endpoints, because there are no endpoints, right?
Just critical points.
If there were endpoints, that would be like maybe an absolute or global extrema. This is only looking for local. So critical numbers, that's it, right? That's the only thing we can really consider. So critical points or critical numbers come for where f prime is either 0 or doesn't exist. Do you remember this? This is old stuff, but we've continued to use it a lot. So we're going to say f prime, and walking around, I was impressed and pleased with the fact that just about everybody I saw the product rule there. That's a potential issue, right? I'm sure some folks might forget that at some point. Hopefully you won't forget that. So you end up with 1 d2 plus 2 d1, and that would be your derivative of f. Any questions? Okay, so we set that equal to 0. And really, honestly, the number one question as I walked around was, neat, I did the product rule. How on earth do I solve that? Right? That was kind of the big question as I walked around. There were plenty of folks that wanted to talk about that. I think there are 2 strategies, one of which actually works here, but it's a bad strategy, and that would be to divide everything through by e to the x. It would work here because e to the x never equals 0. But if e to the x, or whatever that function happened to be, if it ever did equal 0, this would be a bad strategy because you'd lose a solution. So instead of dividing stuff out, what we would need to do is factor. So we'd factor out the e to the x. We'd be left with x plus 1, and still equals 0. And maybe you remember from back in Algebra 1, Algebra 2, whenever there's a product of 0, then you can set each of the factors equal to 0 and solve. So we get e to the x equals 0, or x plus 1, is equal to 0. The one on the right, pretty obvious, x equals negative 1. For what value of x does e to the x equal 0? Never. It never does. That's right. So e to the x never equals 0. You could think of this in a number of ways, one of which would be a graph, right? If you think about a graph, I'm going to erase this. Doesn't e to the x look something like that? E to the x never touches the x-axis, ever. It always stays above. So because e to the x never equals 0, I probably should just write that, right? E to the x never does actually equal 0. We're not going to get any solutions from that factor. But the other one, of course, we did. X equals negative 1. Any questions on that? Some algebra? Doesn't mean it's easy, but it is algebra. Okay, so x equals negative 1. What is that? It's a critical number, right? We need to test this out. It did say justify your answer. So we've got a choice at this point, and I'm wondering what your guys' choice would be or what it was. I have two ways, really, to go about proving that x equals negative 1 is where f has a min or a max. What are my two options? Also known as, because sign chart is pretty generic. We could use a sign chart for several different things, but specific. So either the first derivative test, which is what I think you're talking about, or the second derivative test. First or second derivative test. Of those two options, first or second derivative test, which one do you think would be easier in this case? I think first is easier, right? Because second derivative test, you're going to have to get a second derivative. It's going to be another product rule, and it's not like it's that hard to do, but it is maybe a little bit more than we'd want. So what I'm going to do is the ubiquitous f prime sign chart, also known as the first derivative test, or better known as. And I'll put my critical number here, negative 1, goes right there. I just need to test out values to the left and the right. So for the left interval, what is the most obvious choice to test? For the right interval, which is the most obvious value to test? 0. Thank you. So f prime of 0 equals 1. Yep. So f prime is positive on that interval. And then how about the interval on the left? Negative 2 is a pretty obvious one, yeah. Please, for goodness sake, let's not go like negative 19/7. Let's go with negative 2. So f prime of negative 2, let's see here, wouldn't that be negative 2e to the negative 2 plus e to the negative 2? So that would be negative e to the negative 2. We know that e to the negative 2 could never be 0 or negative, and so the opposite of it would have to be negative. So negative there. Okay, so then our final step would be then to write out our justification. I'll do that off to the right. We'd say f prime of negative 1 equals 0, and f prime changes from negative to positive. So looking familiar? All right, x equals negative 1, therefore f has a min, a relative min, at x equals negative 1. Okay, so what we're doing here is we're tying chapter 3, section 3.3 specifically, all the way up to 5.4. So please realize all these kind of application threads go all the way through. Okay. So do you guys have any questions? Looking around, it looks like you did pretty well. Doing okay with your justifications? Cole, you with us? Okay. Any questions at all? Okay, awesome. Let's keep rolling then. Number 5. Number 5 is an interesting one. I'd say probably for number 5, we probably should have some instructions along with that. Instructions really probably should say evaluate. Evaluate. So anyway, what do you guys think? Do you have the answer yet? Yes. What do you think the answer is? E to the x. So what's your thought process? What do you think of first when you see that? It's the derivative, right? This is the definition of the derivative. So def of derivative. So we've identified that. Then the next question would be, okay, cool, it's a derivative. Then you got to ask yourself, it's a derivative of what? What is it a derivative of? E to the x. And then we're relying on you knowing this, that the derivative of e to the x is e to the x. It's an x, and you're done. Of course, I showed this to you 20, 30 minutes ago, so hopefully you can remember from back then. But what I'm thinking of is I'm thinking of like a test or the AP test, in a couple weeks or several months. You'd want to remember this process, okay? All right. Any questions? Super. Okay, let's move on to some integrals here. I think we're going to time this up fairly well. Okay, so this is all video material here. Let's take a look at numbers 4 and 5, and let's go slow here. Let's please just take a look at number 4. You all acted like that rewrite I told you last time was super elementary. So let's do some rewriting. You know how to do this. See how number 4 goes. Give it a shot. A lot of interesting things going on. I think that this was what I would do. I would start off by writing e to the x to the negative 1 times x to the negative 2. So I'd completely eliminate all fractions of all kinds within the integrand. Once I've done this, I've created a product. Hey guys, created a product right here. I'm going to make a bold statement. Anytime you've got a product like this, where one of the factors is a composite, or maybe even both, you got to think about mess up the chain rule or u substitution. You really need to think about that. So maybe we could do u substitution. If I did that, I want to make my inside function my u. Can you guys identify what the inside function is?
X to the negative 1.
X to the negative 1. You're right. So I've got this. We always find du because I'm going to have to substitute the dx out. So those of you that are averse to writing dx's and du's, this is where you get tripped up, right? Because you're like, I'm not going to write that. You really need to, because if it's not there, the substitution is not going to work out very well. So du equals what? Of course, this is another tempting spot to write this, isn't it? Do you see why someone might do that? You're like, oh yeah, 1 over x, that's ln, right? You're using imprecise thinking and words there. You're going to be super careful. We're doing a derivative. So this would be negative x to the negative 2 dx. All right, so I can then go back and substitute where I get e to the u times x to the negative 2, and then dx could be replaced by du over negative x to the negative 2. So hopefully you can see that the x to the negative 2's would cancel, leaving you with simply a division by negative 1. And so you end up with the negative of e to the u du. And this is where, of course, the finish is very easy. We know that the antiderivative of e to the u du is always e to the u. We end up with negative e to the u plus c. And then our final step, because this is an indefinite integral, would be to plug back in. So negative e to the x to the negative 1 plus c. If you did the Timmy messed up the chain rule pattern, Timmy did mess up, but he messed up just barely. What was he off by? Just a factor of negative 1. You're right. Okay, cool. Hope that went well for you. One reminder, if you wonder, did I get it right or wrong, how could you do a check? Do a derivative. Yes, do a derivative. I agree. Okay, number 5, similar question. Please try it. Number 5. Did you all do this? E to the x to the 1/2 times x to the negative 1/2. I've noticed this definitely can be a struggle at times. This move right here, moving from this to this, because aren't there two things that are happening? You're flipping up, so it's got to change signs on the exponent, but then you're also going from a radical to a rational exponent. And so you guys do a pretty good job with that, but too often, I'd say once is too often. Too often we forget the negative, I think, would be the most common thing there. Okay, so I did the last one with u substitution. I think I'll do this one with Timmy messed up the chain rule pattern. With this one, we ask ourselves, is the derivative of the inside the other factor? So here's the inside right here. So the derivative of x to the 1/2 would be 1/2 x to the negative 1/2. When you check out that other factor, you can see that Timmy almost got it right. He's only off by a factor of 1/2. So if I put that 1/2 in there, then I have fixed his issue, but of course I cannot just do that. I've got to adjust by multiplying by 2 on the outside. Once I've done that, the 2 doesn't go anywhere. We end up with that. Don't forget the plus c. Keep in mind that this is just the inside. It just goes back in. I should probably include that as well. There we go. That just goes back inside, and so it seemingly disappears. There's your antiderivative. You look like you're doing pretty good. Do you have any questions? Okay, cool. So the next section is about definite integrals, where we're going to have some limits of integration. So we'll get through, I don't know, as many of these as we can. It'll set us up well for tomorrow. So take a look here, please, at number 6, number 7, number 8. These are all good definite integrals. So I feel like number 6, 7, 8. I think you probably could do most of these on your own. So give it a shot. Give it a shot. We'll stop with maybe, I'd say, at this point, let's do as many of these as you can. If you can fit them all in, great. If not, I don't know if I'll be able to fit them all in. We'll stop with maybe 5 minutes left and see how it all went. So with a question like number 6, I think there's 2 pretty clear ways you can go. It didn't give you any direction as far as you got to use change of variable or not. And so for me personally, number 6 is not complicated enough for me to use U substitution.
It's Alpha Tuesday. Today we'll be discussing why did Jesus die? Come and join us in the Art Center on the bottom.
I think they're referring to back like 2,000 years ago. Okay. Hey guys, listen up please. I apologize for the interruption. In number 6, I really think what I would do is a version of Timmy messed up the chain rule. I would say that the derivative of the inside is -1. He's off by that -1, so I think I'd put that in there. Number 6, I don't think I would change variables. This is just my personal opinion. I don't see the need to change over to use. If you did that, that's no problem. So then this would end up being -e to the -x, evaluated from 0 to -1. FTC1, -e to the 1 minus -e to the 0. Ben, thank you. And so this just ends up being -e plus 1. That makes sense? So I think, Colin, on yours, I think you must have lost a negative because it's e to the -x. And so when you plug in a -1, it would be the opposite of -1, which would be 1. Where are we guys at? Where are we at? Is that good? Question, Lainey.
Why did you change the integral from 0 to 1 to 0 to -1?
Well, that's my issue. I didn't mean to do that. That's a total mistake. Let's go back and fix that. That's easy. Sorry, Colin. You know, I got to be honest and say I was distracted by just the yakking that was going on. It's really hard when I pause and there's like this. Yes. Yeah. Yeah, essentially, Ben, you're right. And he's talking so much he didn't even know we're talking about him. Oh, now he does. Okay. So let's try this again. -e to the -1 minus -e to the 0. So how about -1 over e plus 1? Make sense? That's what you had, right? Good. I'm glad you did. Glad you did. Hey, guys. Hey. Again. I said, guys. Ben, you're the one that turned around and looked. It was actually Peyton that was chatting. And you say, what's the derivative of e to the x? And you look at the other factor, and it's e to the x. Timmy didn't mess up at all. So, again, in my opinion, going to use is overkill. I don't think there's any need for that at all. I don't think Timmy messed up. I think this just goes back inside. And what's the antiderivative of cosine? Positive. Yep. So it'd be sine of e to the x, evaluated from -1 to 0. So it would just be sine of e to the 0 minus sine of e to the -1. And frankly, you could leave it just like that if you wanted to. There are some simplifyings you could do. You could get sine of 1 minus sine of 1 over e. Oh, that would work too. So anyway, we'll pick up with number 8 tomorrow afternoon. Hope you have a great day. And